lesson of Chapter 6. Chapter 6 is all about expressions, which are very similar to equations, but without an equal sign. So we're not actually going to solve equations in this chapter. We're just going to write expressions using a lot of different mathematical properties. The first thing that we're going to go over today are exponents and what expressions are. So let's start with the vocabulary terms. After the Chapter 5 test, you should have picked up a pink packet with vocabulary terms from Chapter 6 that you've started to fill out. You can use those vocabulary words to help you fill in this sheet. So let's go through it. An expression that combines variables, numbers, and at least one operation is called an algebraic expression. Number 2, you must evaluate in order to find the value of an algebraic expression. 3, blank is a mathematical language of symbols, including variables. And the mathematical language, anytime you see something that includes a variable, or variable means like the letter X, Y, Z, could be M, K, whatever letter. This is algebra. 4, blank blank are terms that contain the same variables to the same power. And we might not know what this means yet, but we will get there. This is just an overview of the chapter. Number 4 are like terms are terms that contain the same variables to the same power. 5, a numerical expression is an expression that combines numbers and operations. For example, 3 plus 4. Here are my numbers, here's my operation. I don't have an equal sign there yet because that would be an equation. So really it's just like 3 plus 4. Okay? Number 6, the base is the number that is used as the factor. And we will go over exponents today, so we do need to know what the base is. So for example, with exponents, if I have 10 squared, 10 would be my base. 7. Equivalent expressions. Are expressions that have the same value. 3 plus 4, 5 plus 2. Those are equivalent expressions. 8. A blank is a symbol used to represent a number, a variable. And like I said earlier, those could be any letter. So H, L, O, P, Q, any letter, really. 9. Each part of an algebraic expression separated by a plus, this should be and minus sign, is called a term. These are very important, or will become very important as we move along to separate terms. So each part of an algebraic expression separated by plus and or a minus sign is called a term. So 3x plus y. These are 2 separate terms. And number 10, the coefficient is the numerical factor of a term that contains a variable. So if I have 3x, here's my variable, this is the number, so that's my coefficient. Okay, it's the number that's usually in front of a variable, is your coefficient. All right, 10th page. Today you are going to learn, so I can write expressions using powers and exponents. Okay. A product of like factors can be written in exponential form using an exponent and a base. The base is the number used as a factor, and the exponent tells how many times a base is used as a factor. So these are going to be, this is actually the factor, 10 is the factor. I'm going to call this actually the factor right there. And then when we try to simplify it, so if I have 10 times 10, I can actually write it in a simplified form, but just writing 10 one time. So that's going to be my base number, and the exponent tells me how many times I need to multiply 10 by itself. Oops, that's just one exponent. Okay, so 10 to the second just means I'm multiplying 10 by itself twice. 1, 2, there's 2 10s, so 10 times 10. So example 1, write 6 times 6 times 6 times 6 using an exponent. Well, what is our factor? Well, here's our factor. Our factor is 6, which is the same thing as our base. So we know our base is going to be 6. And then the exponent tells us how many times the base is used as a factor. 1, 2, 3, 4. So this one is 6 to the 4th. Example 2, write 4 times 4 times 4 using an exponent. The factor 4 is the base. The factor is multiplied 3 times. The exponent is 3. So 4 times 4 times 4 can be written as 4 to the 3rd. Okay, next page. Powers and exponents. To write powers as products, so again, powers are exponents. To write powers as products, determine the base and the exponent. Okay? So example 3 says write 5 squared is a product of the same factor and find the value. So the same factor, we need to write 5. And how many times are we multiplying it by itself? Twice. So 5 times 5 is 25. Okay. Write 1 and 5 tenths to the third power as a product of the same factor. Then find the value. So 5 is our factor. I have to multiply it by itself 3 times. So 1 and 5 tenths times 1 and 5 tenths times 1 and 5 tenths. And for that, you can either do it longhand if you'd like a challenge. I will allow you to use a calculator for this. And if you do, you'll find the answer of 3 and 375 thousandths. Okay, example 5. Let's get my paper up. Again, it's the same type of thing. So 10 is our base. 10 is our base. How many times do I have to multiply 10 by itself? 5 times. 1, 2, 3, 4, 5. And the thing that I like about multiplying tens by itself, it's just 1 times 1, which is 1, and then I add up the zeros. So I have 1, 2, 3, 4, 5. So 100,000. I would like you now to do the back side